Tonight's meetup is our topic is about the MTA and their new bus times. So I'm just here from MTA to talk about the project which installed GPS onto buses throughout here. Jeff from OpenPlans is going to talk about building the back-end web service powered platform. And I'll talk a little bit about the mobile interface practice model of bus time data. Oh, and I want to thank NYU-Poly, this is their space, and it's great to say a few words quickly about the Incubator space.
Hi guys, my name is Stein. I manage the Incubator here, and we opened this around 2.5 months ago. We have around 9 tech startup companies here, and we opened this space for Brooklyn because we really want to be part of the tech community. We're inviting everyone to come here, to hang out, be part of this. We want this to be a 24/7 hub for technology people to just work out of and, take DUMBO to the next endeavor that it really has to take. It's become an amazing renaissance, and we invite all tech startups that are really interested in having a Frumin workstation to apply. And, what we do with the Incubator is not just it's a co-working space, but really help companies grow. So we give them, access to capital, customers, services like legal and marketing, accounting help. And also, help you build your product and build your team, which is one of the most important things people are trying to do this year. So, thank you for coming, and we hope to see you again.
Hi everyone, my name is Frumin. I work at the MTA BusTime project. I'm basically the lead engineer or technical person on the project. So usually when I talk about this project, it's more in the context of sort of transportation industry or agencies or conferences, and in that case, I'm usually focusing less on some of the sort of nittier, grittier, interesting technical details, which fascinate me, and more about sort of broadly how MTA is doing the project and how that's different from how this kind of project is typically done. But I think since this is really supposed to be focused on technology, I'll just talk a little bit about how we're delivering the project from a kind of agency and business perspective, and then I'll peel back the onion on what is effectively sort of a random selection of some of the interesting, complicated things that we had to deal with in order to do something which, at first blush, should be quite simple. So, I really just had, in this context, just this one slide which just gives you something to point at and sort of frame the discussion of sort of what is the system and how does it work. So yeah, I'll just gesticulate this sort of wildly either when I'm making a point or just talking generally, but in overview, what is MTA BusTime? It's simply the ability for us to track our locations of our buses in real time and tell customers as well as internal consumer information where their bus is, which has obvious applications if you're a bus driver and also internally. And delivering the information via sort of however you want to get it, not just a digital sign posted somewhere on the corner or something like that. Really, the key difference between how we're delivering this project and how a project like this is often delivered in the transit industry or government in general is that rather than saying, here's what we need at a sort of high level from this system in general, and who's going to come and do all the work for us and deliver the whole system, and without us really intervening too much in how it's done. What we're instead doing is MTA is playing the role of sort of the overall system integrator and having multiple contracts with multiple different vendors and contractors to deliver different parts of the system in such a way that no one company really controls the whole system, and over the 10 or 20 year life cycle of owning and operating something like this, which between the capital and the overall operating and maintenance cost is going to be in the tens of millions of dollars, that over that whole thing, no one company controls the technology and can limit what we can do with us and becomes the sole source of supply for hardware or for updates to the software, etc. So with that really as sort of the driving requirement from our most senior management, that's sort of what leads to us playing the role of the overall system integrator, and really pushes us towards the direction of using open standards. So what that means is, how is the equipment from the bus communicating with the server? If you were one company and you were always going to be selling your hardware, communicating with the server, it doesn't really matter, you design that interface and you control it and you'll always work it, but when we, need to have the server for one contractor and one or two different suppliers of hardware on the buses right now, it's incumbent on us to define that interface using some open standards so that different people can play in the market and no one says that I'm the only one who can do this for you. So this diagram labels in a couple different places some of the open standards we're using, which may or may not be familiar to people in the group. With respect to what is the system sort of and how is it laid out, not surprisingly, you have a bunch of different pieces of equipment on the bus, and you have a server which gets that information from the bus and pulls in different static information or semi-static information from the MTA, and then it makes it all available through a bunch of user interfaces as well as an open developer API. And sort of one thing that also makes this project a little bit different is that the equipment we're installing on the bus is actually not standard AVL, bus customer information equipment. Some of the components are like a wireless modem that gets you on the Verizon network, but the core sort of computer at the heart of this is actually a computer that is specially designed with a whole bunch of security features that will allow us to do, combined with a contactless card reader, will allow us to support the next generation of fare payment on our buses and subways. So we're basically doing two projects at once in terms of the hardware we're including on the bus, which means obviously less upfront costs as well as one less thing to maintain and keep track of over the course of the project lifecycle. So what we have is basically a computer, which is really a little credit card payment processing computer, the wireless modem, which gets you on Verizon. In this vague sort of notion, they integrate with certain information on the bus that captures the information about what's displayed on the front of the bus, and also what the bus driver has logged into the MetroCard fare box, and also a GPS device. And it sends those up using, like I said, an open standard format. It's actually a web service call. And it sends it up into the server, which I should have labeled as a sort of well-extended and hacked up and temporarily forked and then re-merged version of this software called One Bus Away, which is an open source project from Seattle, and which OpenPlans and Cambridge Systematics have really gone to town on and fleshed out and made a lot of improvements in. It pulls in schedule data the same data that we publish out to developers over the web to make apps with. It pulls that schedule information in. It pulls in some information about, from our dispatchers as to, for a given driver, what work is he doing today, et cetera. It makes all the information available internally, and then, like I said, it has various user interfaces. The most popular one, actually, at this point, is proving to be an SMS interface. So on every bus stop on Staten Island, it says, if you want to know what bus is coming to the stop, send this number to 511-123, and then we text you something back, and that's where Global Commons really comes in, to abstracts away the whole SMS nightmare, which Ben will talk about. And then there's a simple mobile web page and a map, and like I said, an API. So that's really the kind of architecture of the system as a whole. Whenever possible, it's using web services. Like I said, all the backend software is open source. It uses tons of different open source components, SQL, Java, Apache, Tomcat, and all that stuff. And we're running the whole thing on Amazon's cloud service. So, which has its pluses and its minuses, but probably the most important thing about doing it on Amazon was it just allowed us to move really, really quickly, because we were tasked to do this Staten Island project in about 10 months, which in the public sector with a fairly long lead time for procurement, where we write everything, send it out, get it back, negotiate. We had about a 4-month development cycle on the back end, so the ability to just bring up servers, take them down, change them, et cetera, that's where Amazon really was critical, I would say. And so sort of with that as an overall description of the system, I'll just kind of go into a few things that you guys might or might not find interesting about why this is complicated. Why isn't it as simple as just, can't you just put GPS on the bus and throw it on the website? And I mean, conceptually it is that simple, but in practice, it's not. So, I mean, I think really certainly when it comes to dollars, but also when it comes to just the amount of complexity and different things we have to sort through. We have 11 different kinds of buses in Staten Island, 30 different kinds of buses across the city, and whenever you're installing something on a bus, the installation in terms of where the stuff is going to go, where all the wires are going to run, where it's going to get different signals, that has to be individually engineered for every single bus. So for Staten Island, we had to do 11 different kinds of buses, carrying out, surveying, prototype installations, writing up all this, procedures and documentation, etc. And then once you've done that for 11 kinds of buses, then night after night, for about 3 months, 16 buses a night, 4 buses in each of 4 depots, were being installed by a contracted, or by a subcontractor for the folks who were supplying the hardware. And so what's really happening there is you basically have a production line that's turning out product, but it's turning it out, in 4 different depots in the middle of the night. So it's somewhat of a challenge in terms of like quality assurance and just making sure that everything happens the way it's supposed to every single night. And there's fairly standard practices for, post-installation testing and quality assurance, but nevertheless, it is harder to manage something like that than it is to say, well, what software is installed on this server today? And of course, the software and server, if you need to change it, you just change it. But if you screwed anything up and you did something wrong on 100 buses, that's a very substantial cost to go back and fix. Unfortunately, we haven't had to revisit the fleet of buses in Staten Island for anything yet. So that's one of the real sources of just agita, complexity, and effort, and labor, and cost on a project like this. For example, in order to get the information that indicates what's on the front of the bus, there's a little controller inside the bus that the driver can punch a code in, but there's 4 different manufacturers on our fleet in Staten Island. So we had to worry about integrating with 4 different suppliers of that equipment, which again, is fairly straightforward, but when you're doing that as well as doing a million other things, it's just one more thing to keep track of. So I think one of the things that historically is perceived as difficult about this project is that it's hard to get good GPS locations in Manhattan with tall buildings, going through tunnels, under bridges, etc. And actually, in practice, it turns out that actually this is one of the easiest parts of this project, because the technology to combine GPS location with a gyroscope with something that indicates the speed that the bus is going actually comes as a right component that costs a few $100s retail and is built for putting in an automotive environment. It has totally standard interfaces. This little rugged GPS and dead reckoning device outputs GPS in the same format that every other GPS device in the world, even when it's driving through a tunnel, like through the Brooklyn Battery Tunnel. I can see where the bus is. So this little picture just shows, let's see, the yellow is where the bus actually went, right on this little test drive. The purple is what this thing was turning out, and the green is what a normal GPS with no dead reckoning was doing. And so you see the green is certainly a mess. It's not only is it wavering, it goes back and forth sometimes. Here where it's a dotted line, this is where the thing actually decided it had no GPS signal and it was just using the gyro and the speedometer. And so obviously it's not perfect, right? But it's certainly within tolerances that from the perspective of showing usage on a map or calculating how far the bus is from the stop, if you know what route the bus is on and you know what route the bus follows, it's within a tolerance that you could, with decent confidence, just kind of snap it over to the route and present a pretty picture. And so really, aside from the complexity of 11 or 30 different bus types, and the complexity of a back-end infrastructure that has a few different servers and a few different components and a development or production environment, etc. One of the most complicated things actually is figuring out what route the bus is on and what direction it's going and where it's going to stop, because we wanted to do this in a way that had the absolute bare minimum of assumptions. A typical system like this has the driver logged in, and the system maintains careful information on the bus as to what the driver is going to do. And on the bus, it validates what the driver punches in, and it also makes all these complicated calculations on a computer on the bus with tons of information loaded onto it. We didn't want to have to manage a ton of schedule information loaded onto 6,000 buses. So what happens on the bus is it just every 30 seconds reports in what's the bus number, where is it, and what has the driver logged in, and what's showing on the front of the bus. But yet we're trying to come up with pretty good information about, okay, that bus is on this trip, it's going to make these stops with this schedule, and so, but accounting for every possible way that could be messy or wrong. The driver could not log in at all. He could log in with a typo or log in the wrong thing. Or often, when a bus is driving back and forth, sometimes the driver shows the destination sign for one direction, but then doesn't bother to change it when he changes directions. Every possible thing you could encounter. And so we have this really messy, noisy data. The GPS is sometimes off, etc. And we had to figure out a way to kind of make the best possible assumption from all this messy data. And that's one of the things that OpenPlans has really delivered on. A guy who used to do probabilistic commodity trading algorithms, it has implemented something that allows you to basically bake in a whole bunch of probabilistic assumptions about how early or late the bus might be, or how bad the GPS might be, or he might enter the destination sign for this direction but not change it for the other one, etc. And then comes up with an answer as to, well, this is our best guess as to what trip the bus is on and where it's going to stop, etc. And it turns out that it's doing a smashing job, and we have basically not had to deal with any issues in terms of bus operator compliance. Whereas typically when a system like this is rolled out, it's this long period of getting up to speed, educating bus operators into how to log into the system, and how to do this and that, and there's a long period of sort of breaking in the system. Whereas for our project, for Staten Island, like I said, we basically started the production work to procure and deliver Staten Island in basically February or March of last year, and we launched it the first week of January of this year. And in the most literal sense, we launched the project on the absolute soonest possible day that it was even remotely launchable, without any kind of ramp-up period for the operational staff to figure out what do they need to do to make it work, etc. And that was largely because of the work we did to sort of build in the tolerance for just messy everything. And I think with about 15 minutes behind me, I don't know, I mean, I could talk about a lot of other random things, but I suspect that it might be more interesting if people have questions either about, other details about how it works, or what the role that MTA plays, or what I do on a daily basis, or whatever. So, yeah.
There's a couple of different companies that are doing the street view technology like what Google uses, and they had to deal with that same problem of how do you know exactly where this car is when it's taking these videos. They came out with all sorts of, some of them open source, some of them not, solutions for it. Did you guys look at any of that when you were figuring out this pathing, or was this solution, did it come up pretty quick, the hardware stuff?
Yeah, I mean, so I don't know what all the solutions are. I know that, for example, we've done some tests with Skyhub, which, pulls together Wi-Fi and GPS and 3G triangulation, and it's definitely more brittle than this. So no, we didn't, aside from Stein, we didn't really look too much, but I think the part of what affected that particular decision is that, here's a commercially proven solution, it's in a rugged box, and when you're doing something that, if you screw up, you have to go back and revisit 800 or 6,000 buses, that's the area where you really want to minimize your level of experimentation and risk, because what's on the bus better work or you're in big trouble. On the server side, I'd say we've taken a lot more risk in terms of what we're willing to develop new. So no, I mean, once we saw how well this was working and that it was rugged and off the shelf and it has a standard interface, so in the future, if someone else can build a box that uses Skype or something else that produces sufficiently high quality, when these things start expiring or breaking and we need to buy new stuff, it's cheaper. As long as it has the same interface, then we can always evolve in the future. Yeah.
I saw you have XML somewhere there on the screen.
Yeah.
What are you guys using to, I guess you're transforming the XML with something, what are you using? Could you talk about that?
Yeah, so what's coming from the bus to the server is a web service HTTP call. It's using JSON for interchange because it's a little more concise with respect to saving wireless bandwidth. And TCP is this FTA APTA standard that's been developed for a long time, and may or may not ever really see the light of day in a broad sense, but define at least one message type that basically had everything we needed. And we wanted to have it be ASCII based so that any vendor, if vendor hardware, that might not know how to use protocol buffers, for example, or something, can generate an ASCII string and post it over HTTP. So that's that. The schedule comes in GTFS. I don't know if anyone's familiar with that. It's sort of a CSV format for representing transit information. The information coming out of different MTA systems, like the system that knows which depot each bus is assigned to, or what piece of work a given driver has signed up for that day. That's using another TCP, this time encoded in XML. And then what we're producing, the app developer that also actually powers the own UIs, it's available again as a web service in either JSON or XML, and it uses this thing called Siri, which is a European specification for real-time public transportation information that's really for customer-facing stuff that is pretty mature and well adopted in certain contexts in Europe. But actually, we're the first ones to use it in a sort of like mobile phone and public developer-facing context with a RESTful interface. And actually, Jeff and I were on a phone call last week with the CEN, which is like ISO, their committee, about taking this stuff and actually baking it into the standard, and they're psyched about it.
So you guys kind of hacked the Siri stuff into that open source.
Yeah. So since we have this mandate to use open standards, we wanted to have an open standard that was developer facing, and Siri was by far the most sort of mature and robust one. We just tweaked it a little bit to be more, Web 2.0, JSON and RESTful stuff. Yeah.
I know that San Francisco has a system in place, was my understanding, for a while, although I've moved and I haven't tried it. But yeah, did you guys contact them and talk to them? And is there a difference in the system that's based on different needs in New York and San Francisco standard?
Yeah, so I mean, we talk all the time to folks at other agencies just to learn from their experience. From where do you install equipment on buses, or which little relay do you use to control how long each hour, up through how do you work with your schedulers to get more frequent updates so that when a bus route changes, through certain things about how customers use the system to understand what really you need to provide, etc. So we actually, San Francisco is actually not one of the places we have a direct relationship, but Chicago, Portland, Boston, London, those are places where I know some folks, and it's a little different everywhere. And so yeah, we definitely have taken advantage of a lot of the learning that's happening in the industry, but of course, our solution is different from theirs, more as a function of this mandate to deliver in a way where NTA really controls the future of the technology and the ownership. As that really drove a lot of decisions as to how to do that. So, I mean, this is the first open source, first deployment of any real size of an open source, bus AVL customer information backend. So if we get sick of OpenPlans or Cambridge Systematics in X years, we can rebid the contract and someone else can add it, maintain it, and that's great. Sure, go ahead.
Well, sort of two things. One is, you say it's open source. Does that mean all the code is actually open source? So if I wanted to go and take a look at it.
Yeah. So also the core One Bus Away project is like a fairly, it's really one main developer who now works at Google. But there's a mailing list in the community and everything, and it's pretty well documented, etc. We basically have the core module plus a whole bunch of other stuff we've built. And all that code is available like at a particular repository on GitHub. And what we actually were just discussing today is the process by which we're going to work on sort of making much of the documentation and the feature and bug stuff, making that all, making the parts of that can be open. So the stuff that specifies, the deployment and the passwords and the IP addresses for our servers can obviously be open, but as much as possible, refactoring all the documentation, but the code actually is. I just wouldn't, you don't want to look at it until you've read some of the applications.
For the access to it says like app developers, what's the process for someone to get access?
They just submit a Google form and then you send them an API key and it's fully documented. So, yeah. I think you had your hand in that.
So, can you talk about the scale of this? Like, you got 6,000, well, you will have 6,000 buses, but so current scale and projected scale on that API, and then I assume it's not actually just one CIS server, there's gotta be something,
correct.
so. And then scale on the API side?
Yeah, so, I don't know, Jeff, do you want to talk about that when you come up, or? So, I mean, yeah, one of the main pages on this wiki that we're trying to figure out the right way to make open is a picture that describes a bunch of these sort of server-side components. So, the primary, so I'll just sort of walk through it really briefly. There's a server that runs a HTTP that gets these messages from these buses, which ultimately would be something like 12,000 a minute, which is, I don't know, for HTTP server, it's really not, that's not that much. We'll have like one and a hot spare. It takes those messages and just drops them right on a queue from the zero in queue, is like the software that allows you to pass messages around. From there, the data goes to a few places. It goes to one client of the queue that just takes the data, puts it right in the database, just for archive purposes. Then each depot, so the most computationally intensive part of this, and it's also a process that's actually stateful, at least for now, is the thing that figures out what each bus is doing, because the algorithm like keeps much of state. And so for each depot, well, each depot is fully managed on one of those servers, and then there's a hot spare of those. But if it's a small depot, you might fit two on like one box. So each depot subscribes to like the message broadcast and gets the information for the buses that it's looking for, and then does the calculations. There's another message on the queue, and then there's N sort of user interface machines that get those and update state they're keeping. But actually, everything in this, the whole thing is all basically in memory. So like all of this information gets compiled down into this like highly indexed structure that all the different components use as the sort of reference basis. So what gets communicated between them is actually very, very small amounts of information. This bus is on this trip at this location, on this block, with this scheduled deviation maybe. And so we've gone horizontal when we can, like on the front ends, and yeah, so hopefully that gives you a rough sense of it.
Sorry, it just serve the various interfaces, so there's a different server for each one, or multiple?
No, so this is all, the front end servers, which are totally horizontally scalable, those serve all the customer UIs and the APIs.
Right.
So
And
you're just,
how many do you run now? Like, how many do you need for whatever?
I mean, we're running 5 right now, but I actually think we probably don't need that many right now, because we over-provision for the launch and stuff. And as we sort of stabilize the development cycle, what we can obviously do in something like AWS is run more of them at certain times of day and fewer at other times of day, so, yeah.
Let's do like one more question, and then Jeff will talk like a few more at the end.
Mine's a double, but I've been waiting for this forever, so bravo, thank you. The first question is, why the decision to include the payment thing? Because a lot of the select buses have the payment on the street while you're waiting for the bus. And second of all, how is this different than aren't you trying to set on like 34th Street with the?
Yeah. So I'll talk about 34th Street first, because actually this weekend we're going to switch over from that system on 34th Street to BusTime. So, but to be honest, what's on 34th Street? It announces on the bus the next stop. It has signs at the shelters. It tells you with an unknown level of accuracy from our perspective how many minutes it is as compared to just 2 stops a day. Or like right now, we're not
just based on the schedule, not actual.
Well, no, it uses GPS and everything, but we're not actually making predictions about how long till the bus comes to you right now. We're just saying the bus is 3 stops away, 2 stops away, 1 stop away. So what's on 34th Street does a lot of stuff, but it is a system that is end-to-end, one supplier, their hardware, their server, their interface to the server, everything. And that was basically unknown for 6,000 buses. So that's what's on 34th Street. The other question was about the payment stuff. So, yeah, I mean, the payment project to replace the Metro card is about 10 times the price of something like, it's a project that's 10 times as large as this. In price, in complexity, in tolerances, when you're managing billions of dollars of revenue. So really our project, with respect to the on-bus stuff, is actually just a little application running on a new therapeutic system. It's just that that system has a longer sort of arc of development, and so we happen to be the one that are putting the hardware on the bus. But once that payment system is sort of being designed and developed, it'll be a software update on the bus, and then that's like part of the payment system. So,
You would have had the funding without that.
well, I mean, if we didn't have the funding associated with the payment system, we would have probably done it even, found it even simpler and cheaper, right? I mean, so for example, the total on-bus cost, we've allocated a fifth of that cost to this project, and the rest to the payment project, because that's really what the MTA needs to do over the next few years to retire a 20-year-old MetroCard system that, you know, does a lot of great things, but has its own limits, so, yeah. I'll give you one second.
How should you monitor the traffic coming from SMS, web, PCs?
Yeah.
So like, what is the breakdown more or less?
Yeah,
Where
so-
the traffic is coming from, and like how many people are using this?
So we've got overall about 10%, you know, for every person boarding the bus, we get about 10%, like 1/10 of that request for the system. Like actual individual requests, not each CSS, you know, not each HTTP request. And it's about half SMS and half sort of internet, mobile and that.
How many people are using this?
So if Staten Island has about 125,000 riders per day, roughly 10% is about 12,000 per day right now. Great, thank you.
Hi everyone. I'm just going to talk a little bit, instead of about the technology, I'm going to talk a little bit about OpenPlans. We're one of the contractors who work on the project. So my sort of spiel is hopefully not going to be salesy, but instead be a little bit about sort of political. And I don't mean political as in the state of New York, but just political as in how this thing will sort of develop in the world. Everyone hear me? I guess so. So OpenPlans is actually a not-for-profit. We're based we have our office is on Lafayette and Grand. We're based in Soho. Our projects include street blog or street films. Any readers or watchers in the room? Yay, all right, yes. One of our projects is OpenGeo. OpenGeo works on our foundational GIS software. CivicWorks is the group that brought you the bike share. Everybody vote for their favorite bike share location, hopefully. Open 311, which maybe you're familiar with. 311 is, of course, the service to report to the city about potholes or signs or traffic lights that don't work, so trying to make that open. And then the group that I co-direct is just a transportation group, and we worked on BusTime with the MTA. So to tell you a little bit about the transportation group and what we actually do, we do a combination of notes here too, so I have to look backwards, but we do some work with future service consulting, and we sort of define ourselves as building both foundational and transformative platforms. I know that's a little buzzwordy, but I think the two sort of important aspects of that are foundational in the sense that, well, maybe I'm kind of skipping ahead, but we build software as infrastructure, so we're less about sort of apps and more about the things that power apps. And then the transformative aspect being the sort of unique needs of progressive transit agencies. I mean, the MTA is taking a very sort of innovative approach to sort of solving these problems, and so they need someone who can kind of like, you know, what do I want to say, pivot along with them to sort of get those things executed. So that's sort of how we define ourselves. And I think one of the important distinctive components of what we do is that it's, we sort of co-develop our platforms with the people that we work with. So it's less about bringing something off the shelf in and actually listening to what agencies need and sort of developing something in concert with them. Which could also be useful whether you're in the public or the private sector. So because we're a nonprofit, we're sort of unique in that we do what the market doesn't do. And so that's kind of partly why I wanted to talk more about a nonprofit, is because as a startup incubator, it's like, well, you know, what other sort of organizational structures are there out there, and how can those sort of work? So, you know, we sort of exist in what's sometimes called the third sector, civil society. And so we sort of compete less in the market and do, again, kind of do things, I guess the best way I framed it is up there, do things that the market wouldn't necessarily do. And sort of, first and foremost, it's our founders' belief that we need to sort of work to break the coordination problem, which, you know, those familiar with like game theory and the Cold War and whatnot, that might, Nash equilibrium, it might sort of be something you're familiar with. But the idea is that if we can get everybody to sort of act in concert, everybody can receive a better outcome. So Open source is a great example of that in the sense that, if the MTA in Portland and Seattle and, City D can sort of all pool their resources, they can all sort of get a better bus tracker and all benefit from that. And the sort of value behind that is that ultimately cities aren't really competing with each other. They all sort of exist in parallel tracks, but it's like there's always going to be a sort of distribution of folks in the city, so why are we sort of procuring software as if like, a bus tracker is a sort of distinction for a city to achieve. So, and then lastly, we sort of frame our work as providing a public option, and that includes both the user interface, and that also includes both the project itself being something that sort of pushes the whole industry forward. Is everybody kind of familiar with the notion of a public option? I know that's kind of another buzzword, but it can be a question later. So, next slide. So what's different about this approach? This is probably the question that I get asked the most. How are you different from a traditional software vendor? I think there's a lot of things. These are in no particular order. Sorry, I kind of just like threw these together, and I probably should have ordered them. But I think one of the unique qualities of what we do is that in the end, the agency owns the software. We're less about a traditional approach of selling the MTA something, and you could kind of hear Mike recount how this was a sort of issue with other systems and one thing that they wanted to deliver deployed, but vendors like to sell large government agencies something that they can sort of derive revenue from year after year, and that's great for that sort of vendor's balance sheet in the sense that they can sort of know that recurring revenue is coming, but it's not necessarily good for taxpayers. We give our source code away freely, and you heard Mike sort of describing the key benefits that if the MTA is not happy with our organization and the way that we're servicing the MTA, they can take the documentation, the source code, and the knowledge that we're sort of hoping to impart about the system and take that elsewhere. So that's super important. Keeps everybody honest, including ourselves. And part of that is also, you heard Mike mention Cambridge Systematics. I don't think there's anyone from them in the room, but they're a great organization. They're actually they're a for-profit. They've been around since the 60s or 70s. They're a lot sort of more traditional in that way, but no offense to organizations that have been around that long. But they are usually working on transportation modeling, and sort of as they move more into the software world, they're interested in sort of alternative platforms. So it's our interest to bring someone like them who have like a track record of supporting these long time horizon systems to the table to sort of give the MTA that sort of logistical partner to have the system be supported 20 years, 10 years out. So you already heard Mike talk about open standards. Open standards are important just to be able to replace certain components of the system without any sort of input from us. I mean, compared to an end-to-end system, the MTA can choose to replace any component of our system tomorrow with a standard interface with something that matches that same interface. We sort of build true platforms. I put platforms in quotes because this is a sort of often used word and it's used in sort of a squishy way, and that's always where you get into trouble. But we're sort of believe that true platforms include both like an absence of legal and technical encumbrances. And you get a lot of data that's like open but not in the right formats, or there's certain parts missing. And I'm not going to sort of go into specific examples of this because it sort of get a little pointed. But it's our goal that this data is actually sort of unencumbered and it's freely available and it's made as usable as it can be. And that goes from both an availability perspective and from a surfacing the ways developers work. And so an example of that is Mike and the MTA looking into making Siri more accessible to developers using codings like JSON or Web 2.0, RESTful URLs, things like that. So I've already sort of talked a little bit about open source as something others can use. Maybe I want to revisit that. And just say that I guess another sort of interesting issue of working with the public sector, and one that's very different from startup world, is the high cost of failure and the long support time horizon. I mean, our team and our product can't disappear if OpenPlans like folds tomorrow because we went to snacks, or our office is too lavish and we can't make payroll. Sorry, MTA. That's not an option for us. So that's why it's really important that we carefully consider our decisions. We choose technologies that have broad installed user bases. Lots of developers are familiar with this. That's why it's like struts and Spring, which maybe isn't that cool in Web 2.0, but lots of people know it. And also bring someone like Cambridge Systematics to the table, even though strictly sort of self what I want to say, a sort of self-interest sort of sort of selfish framework. We would want to do all that work ourselves and get paid for all that, but as a nonprofit, we're sort of trying to mix in another factor in our decision. So two examples of this kind of like open source co-development, sort of everything I've been talking about, working really well is obviously BusTime. BusTime was a project that started with one bus away, an open source package that Mike already said, was developed by a guy named Brian Ferris at the University of Washington, a PhD student, launched it in Seattle, and then basically adapted it to our needs. And then the other example that our organization is responsible for is Portland TriMet. They have a, has anybody used their trip planner before? Anybody from Portland? No? All from Brooklyn? Okay. So I see a lot of nods, all right, good. I'm not, but, so Portland TriMet has been working with OpenPlans for like a decade now to build an alternative to a trip planner that they had previously procured from a proprietary vendor, and we're paying upwards of $50,000 a year just to sort of support that. So we want to sort of blow the door off those kinds of models and sort of really provide something that includes a higher level of support at a lower price point with some innovative features. So if you haven't gotten a chance to try out the Portland trip planner as a little plug, it's got a really cool what we call a bike triangle that allows you to specify that you want a biking route along 3 different sort of optimization dimensions or a mix of those, and that is like safest, quickest, and flattest. And then, so just to give you kind of an overview of what the whole process was from, and this is sort of course, super cursory, and I'm happy to talk about any of these steps if there's any interest, but One Bus Away sort of originally started as an open source project that OpenPlans wasn't affiliated with by a guy named Brian Ferris, who again is a PhD student at the University of Washington. It was launched in Seattle. It was sort of, in the classic, startup sort of, what do I want to say, like sort of, sorry, I'm like short for words today. In the sort of classic like story, he scratched his own itch, so to speak. Wanted to know where the bus was. Built a system over 5 years that told people where the bus was, and sort of launched that in partnership with some of the agencies there, getting the data from them, and sort of presenting it. Sometimes maybe more partner, sometimes maybe more existing on the outside. We sort of received the MTA's RFP for a pilot project. The project started out as maybe some of you know on B63, and it was a pilot project that was intended to be done on one route as a test to make sure the content that the MTA was sort of considering internally worked, and the hardware worked, and the software worked. So the pilot was then deployed in the B63. Everything was great. If any of you live on the B63, you've been using it prior to January, and hopefully you like it. The MTA released an RFP for the citywide process, which Cambridge Systematics and us sort of worked together to respond to. As Mike already said, the development timeline was crazy. I said a few months because I wasn't going to put a number to it. I would say 3, he said 4, but I wasn't going to do it. But there was a long procurement sort of timeline where we lost some time there. So I mean, for an organization to be able to sort of throw together, put the pieces together that quickly, I think was a big pat on the back for everybody. So pat on the back to us. And then, of course, as the, I say then everywhere in quotes because the MTA, I think, on one of their subway signs, they sort of half joke with themselves that the data would be available on Staten Island and then everywhere. So that's kind of the next step, is that you'll see it roll out to the rest of the city in the coming year, and what's left of this year and the next year. So I think that's actually all I've got. Yeah. So anyway, happy to take any questions now or later, but maybe I'll let Ben talk a little bit about mobile commons, and then we can talk about the whole thing afterwards, but thanks for your attention.
So Mobile Commons provides the SMS, text messaging interface to BusTime. This is the MTA sponsored version of this. They opened up the data to be open to developers of all shapes and sizes, and I forgot to mention Scott is here. His startup Roadify actually pulls in this open data to make your iPhone app, and he's going to talk about it a little bit when I'm done. But this is what the SMS interface looks like. 511123 is the short code. It's a 6-digit phone number that belongs to the MTA. And if you text in your stop ID, which is posted on the little placard next to every bus stop, again, now rolling out citywide shortly, you'll immediately get back the real-time information about where the bus is off. And you can sort of see, if you keep doing it over and over again, these numbers could get smaller and smaller if the GPS is working properly. But what I wanted to do is just take just about 5 minutes and drill down and say, okay, what does SMS technology really look like? And I'm going to geek out for a minute here. So at a high level, this is what the picture looks like. So you have your iPhone and you text in your stop ID. And that should be clear, you can also text in an address or an intersection. and they will geocode the address and send you back the route that matches where you are. Right? This is sent in, hits your carrier, AT&T or whatever, which is then sent via a protocol called SMPP, and that's what I'm going to talk about for a second. Bulk Commons gets that message, goes out to the BusTime server over HTTP, gets a response back, sends the message back to the carrier, and there's probably a cloud around this picture, which I'll get to in a second, and then it goes back to the handset. So probably, if you've written code, I'm sure you've sent a text message at some point, either using a free API that's available, there's a handful of them, or maybe using email gateway, where you can send an email to a phone number. There's really, really easy ways to just send a text message. But then when you start to do it at scale, and you start to do it for hundreds of thousands or millions of messages, what's actually going on under the hood? How are the carriers talking to each other? How are application providers talking to the carriers? And so there's a protocol called the Short Message Peer-to-Peer Protocol, SMPP. Right? So it sounds like the email protocol, SMTP, but it's both similar and different to that protocol. So this is used to send and receive the messages. Historically, it was a test protocol. So an engineer who wanted to say, hey, are the telecom servers up and running, would be able to send a single packet up and get a single packet back to verify that there was connectivity. And that's why you have this 160 character limit that you're so used to, because that's what would fit into a single packet. So the architecture is based on a PDU, Protocol Data Unit, which is a binary message, super small. It has the handset, it has the sender, the receiver, and the message. And that's basically it. And then it gets packed into a little binary message and is sent off to the carrier. It's all very, very asynchronous. So if you imagine HTTP, when you send a message, you make a post and you get a response back. And it blocks and it waits for that to respond. That's not the way it works in text messaging. The way it works is you have a client. In that picture, it would be mobile commons connecting to the carrier, Verizon or whatever. And there's a persistent connection between those two, between the client and the server. And one will send a packet up and just waits for asynchronous response. So if you imagine this is an evented architecture, so something like Event Machine or Twisted or something, if you can use open source languages, it's that kind of model. So you send messages, wait for responses, and it runs as a transceiver. Because if you imagine you're sending text messages and getting text messages back, so that goes in both directions I mentioned. Transceivers, transmitter and receiver, goes both ways. The semantics are stored and forward, right? So that's sort of the way email works, right? You send an email, you send it to your ISP, it makes it the next hop. It goes, hop, 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 hop. Each way through the internet, it gets stored at a particular server and gets forwarded on. And that's why you get something like, oh, this message could not be delivered for 12 hours, we're still trying. That's where you sort of start to see the store and forward semantics. And SMS is actually very similar. And the reason is because there are a lot of carriers out there. Right? We know of probably 5 big carriers, let's say in the New York area, but there are well over 100 carriers in the United States alone. Some very, very small regional rural carriers that maybe have 20,000 subscribers. And so it's really hard for any given company to have connections, because again, these are not lightweight connections. These are persistent, secure connections. So no one has connections to every single one of these carriers. So you end up having partners sort of throughout the country that connect to, kind of these fan-out nodes, as you can imagine. So we'll send a message to a gateway partner who may send it off to a rural, this doesn't make sense for something in New York City, but in the Midwest, we'll send it off to a partner. So they're stored forward each step of the way. And then you get asynchronous responses. So when you're in HTTP land, you make a request and you immediately get back 200 OK, 500 server error. In this case, you send it off and then you wait. And you wait to get a response that says it was received by the gateway, it was received by the carrier, it was received by the handset. And handsets, modern handsets will actually send back a delivery receipt so that the server or the client connected to the server can find out that it was delivered. And that process can take seconds or it can take days. If you imagine you're traveling, your phone is off, you're in airplane mode, that text message doesn't get delivered. So it's up to the client who's sending that text message to basically just wait. Maybe, again, it may take 4 days before we finally find out that message was delivered. It's a huge variance there. And then I'm going to drill down to the 160 character limit. So to be very specific, an SMS is 140 bytes. Right? And if you have an 8-bit alphabet, which we're mostly used to, that translates 1-to-1. So you have 140 characters. What they sort of figured out is if you're talking about ASCII and you're texting mostly in English, you can compress that alphabet into only 7 bits, and that lets you fit a few more characters. So you can get 160 characters into 140 bytes. And yeah, the corollary, if you want to send text messages that aren't ASCII, right? So something in kanji that's going to be a double Y Unicode character is going to take up twice as much space. So there you have a limit of 70 characters. So yeah, it's sort of interesting little technical details about the way SMS works. And that was it. So I'm going to hop off and that's the viewers. There's some questions for the group.
Let's just do that overall balance. Can anybody see this? I'm with Roadify, Roadify, and if you'd like to download the app and see them close, it's an iPhone app, it's a free app, so feel free to do that. Then asked me to speak just for a couple of minutes to kind of show you what the output of what these guys have done gets into the hands of people who are just trying to find out when the bus or the train is going. Just a quick background on Roadify. We actually cover all the transit systems in the New York metropolitan area. So subways, buses, Long Island Railroad, etc., PATH, and a couple of smaller systems like these buses from downtown. And we are in San Francisco, Seattle, Austin, as well as New York City, but we started here in New York. So what we're really focused on doing, we're not a routing system, we're not a route planner or a navigation system. We're really focused on regular riders, people who for the most part know where they're going, they know how to get there, and what they want to find out is where's the bus? Sorry, I'm just blinded by that. Where's the bus? Where's the train? And if it's not here, why? And so what we do is we combine official information from official agency sources, and we combine that with user-generated content in the form of Twitter comments that we can textualize by route or by system, as well as comments that our users themselves are able to make within the app. So to give you an example, just to show you here what we've done with the MTA data, actually let me back up here. What you see here is a list of the most recent bus lines that I've looked at just a few minutes ago, and then taking the official advisory order from the MTA, we show whether there's planned work on that route or on routes near that route, because the way it's grouped, we'll talk about that a little bit, or whether there's a delay, in which case I'm not seeing any delays here, or if services that the MTA is reporting that service is normal. So when you see a green icon, what you're seeing is service is normal. When you're seeing a yellow one, that means there's some kind of planned work, and if this were red, that means that there's actually a delay of some sort. So let's tap through here, take a look at the B63, and what we want to show you is how this real-time data gets presented and visualized for an end user. And what you're seeing here with this little, this is the B63 in Brooklyn. It runs from Bay Ridge, between Bay Ridge and the end of Atlantic Avenue in downtown Brooklyn. And what you're seeing here is, the way we present it is by trips, that's what I talked about. So this trip is the trip that began at Brooklyn Bridge Park about, let's see, 2 minutes ago. And here's where the bus is now. Right now, that bus that began 3 minutes ago at Brooklyn Bridge Park is somewhere on Atlantic Avenue between Henry Street and Clinton Street. And now down here, where you see the icons, you'll see in how many minutes the bus, you can expect the bus to arrive at that, at that specific location. And what we're doing here is we're taking the location information from the MTA, and we're comparing that to the schedule, and we're able to thereby determine the amount of time that it typically takes. And those schedules are pretty good because they're based on vast amounts of historical data. So we take that, we make the calculation, and we give you this countdown. And you can switch between, you go back to your previous trips, you can swipe, and keep going like this, or you can see, in the future. And then if you tap, let's see, let's just tap here. So what you're seeing here then, across the top here, are the next 5 expected arrival times for our Atlantic Avenue and Clinton Street. And if we have the real-time data available, we show that, and you see the icon, and we credit the MTA with that. And then the next projected times thereafter, which in this case would be based on the schedule because those trips haven't yet begun.
Sorry, could you talk a little bit about how you sort of became the developer of it, or consumer of MTA data? Was it as easy as a Google form?
With quick history of the company, we actually began as an SMS service for people to be able to give and get parking spaces in Park Slope using text messages. And we added to that the B67 line. People could text in where they saw a bus, and we would use the bus schedules as we do here to calculate, how far along the route that was. And then people could get that same information by text. And then we expanded that to all the bus lines in the city. This was before the B63 experiment began, and certainly before Staten Island deployment happened. So what we were doing was giving people the ability to report a bus location via text. Then when we first launched our first iPhone app, we gave people the ability to give a bus location, which, well, let's see, it might not work here because this is real time. Maybe I'll just go back. You can still give bus locations. Here, I'm just picking one arbitrarily here. You can still use the iPhone to give bus locations. Now, obviously, that's going to be an obsolete feature as the MTA rolls out Manhattan and the rest of the boroughs, and as most cities move to that. But in other parts of the world, and in other cities where they don't have the level of sophistication, cities like New York or San Francisco or Boston, et cetera, have, that is a capability that some people like. What we found, though, was that crowdsourcing the bus location really didn't scale sufficiently. It didn't scale to the point where any bus anywhere in the city, where the information could be relied upon to indicate where the bus was. So we kind of shifted over to this real time where it was available, or scheduled information where it was available, and that combined with the crowdsourcing part of the service being more in the form of user commentary than the location. But from a capabilities perspective, it's still there. The other thing I just want to show you very quickly is the user comments. I just want to go back to that here. Because one of the cool things that we're doing is scraping Twitter. And people, we're able to read the tweets and determine what subway line or bus route or whatever people are writing about. And so we take that information, we organize it on the same screen with the official information that's coming, or the schedule information, as the case may be, that's coming from the MTA. So it's official plus crowdsourced information, commentary, all in one place. I also just want to compliment the MTA. We were at that RFP, which actually moved in the spring, I think that's what it was in April, right? And these guys said, we're going to have all of Staten Island deployed by the end of the year. Right. And by the end of the year, they had all of Staten Island deployed. And it actually works. I mean, occasionally GPS goes out on a bus here or there, and stuff happens, but it's been remarkably stable. And just congratulations on the fabulous success. Questions?
Let's go through some questions, and then we can follow Kolber. We got it here.
When will Roadify be available on Android?
We hope later this year. It's just been a resource issue. We very much want to be on Android. kills us that, we're just not able to get, that's a user base that we're not able to address yet, but we will, definitely.
Good question.
And I noticed, I think you said that the data that the MTA puts out does not have any timing issue, any timing information. So that was something that you had to sort of add as a value on. Is that something that the MTA is thinking about adding at some point, or?
Yeah, I mean, the MTA is very careful about, when we make statements, we like them to be sort of reliable, right? And so in the time frame that we were working, we didn't feel like we could do everything I explained, plus implement, test, validate a prediction algorithm on top of all, which is why we're doing something as simple as what we could do for sure, which is the bus is there. And I think it's a good experiment actually in sort of seeing, now that we've done the really hard, messy part of putting equipment on buses and figuring out each bus what's it doing, what can the market provide? And I think, what we want is to make sure that our customers get the service that they really want, right? Whether they get it directly from our interfaces or from app developers, whether we provide predictions or other people provide predictions, some of those things remain to be seen. Our primary focus right now is just getting the equipment installed on 5,000 more buses and making sure the server scales. And then by that time, we'll see where we all stand. So,
And is the historical data available via the
we did
API?
not through the API. We published like 1 month's worth of data on the B63. And I think that if people wrote into the developers list and asked for some historical information on Stein, we probably wouldn't say it.
I would just add, for what it's worth, us we're looking at the Siri data and we're looking at the GTFS schedule data and doing calculation comparison. It kind of slows the processing performance issues that we're seeing on our end. We would look to see real-time data available to GTFS.
Oh, I see, with the real time.
Yeah, so that it's all GTFS, and our developer has also, our lead developer has also said to me that GTFS actually processes a lot faster than Siri. I don't know if you've seen that.
I can see by what he's saying. I would say what he should do is send some comments into the developer list and let us know what people want.
Yeah.
I was wondering, I've seen the display maps used as a display for some of the UIs. I was just wondering, now Google's charging for that. You guys can use those tools, or wasn't it?
We are using Google now. We are paying something for it now. What exactly we will do next is not decided.
Okay.
Yeah, I think we're still under the charging threshold for maps. I think there's actually a legitimate question in an application like ours, which is about conditions and not so much about routing, as to whether maps are even necessary. And that's sort of that's an iconoclastic kind of statement to make. But I think we're just at the beginning. Location-based services are fairly new into consumers' hands. And so our maps, in the way that we traditionally use maps, the best way to visualize the kind of data that we're working with. That's an open question that a lot of really smart, creative people are really just beginning to grapple with.
Is that the overall big picture that we just take? That's exactly where you are in the next process. The big picture.
The big picture for
data and things like I go to a bus stop and I go on pushing it and all the
well, we're headed with our app and with our design and our user experience is what we say. We say just take as much friction out of the system as we can, so that we can get people to the information that they care about, that's most relevant to them as quickly as possible. And that would either be in one tap to like a favorites screen, so that you see across transportation modes or across different lines. Some people might take a bus to a subway, other people might transfer subway lines, some people might go bus route, buses. Some people might take the path to the subway, so that they're not only crossing vehicles within the same system, they're actually being crossed different systems. A lot of interesting data problems associated with presenting that and organizing it all in one place. So one tap is kind of what moves the way for us. And then beyond that, just pushing that information to people at certain times of the day when they might want to have it pushed to them, by having it be there on your phone when you wake up in the morning, so you can just see right away when you pick your phone up what to expect and what to do that day.
Do you have any, from the server side perspective, do you have any plans to make the subway location information available to the same services? Or is that data available where you can push or somewhere?
Yeah, I think the MTA is generally sort of moving in the direction of open data in general, BusTime being a project that is helping sort of value that. But I work on the BusTime project, so.
Is that it exists somewhere because you go to the subway and you see how many minutes?
It must.
It's going to happen. It's going to happen. And we've got it in San Francisco. I'll show you this. We've got real-time bar data in San Francisco, real-time data in San Francisco. And what's really cool about San Francisco is that BART has underground connectivity. So you can get this information. You have a very different kind of experience with data and information and services like this when you're in San Francisco. I was out there a few weeks ago and I used Google Transit to ground myself. And I was using Roadify along the way to kind of track my progress and figure out how long it would take.
So, I want to thank everyone for coming up for the first